Hello there, great person. Hello, and welcome to this new reaction to something sciencey. Today we're gonna watch Journey to the End of Time, and it was suggested by Andreas Gaming 97. So yeah, thanks, mate. I will watch it gladly. It's quite long; it's half an hour. So yeah, it's about, I assume, the death of the universe, the eventual death, and yeah, let's see what they are doing here. Probably, yeah, I'm not gonna speculate which one they will take. Are they gonna go with big crunch, heat death? What are they gonna do? But it seems to be quite exciting, and let's just get into this. So yeah, for my background, perhaps if you're new here, I'm a physicist, but not an astronomer. So I've heard some basics about that. But I will nonetheless comment on this as far as I can, and perhaps give you some insight about things I think that I might add on to this, or perhaps even just be it or what I see. I don't know. Let's just get into this and have some fun with it. So yeah, let's just start it. Let's go. Yeah, protocol lapse. Does the future hold? But look like probably not in a literal way. But we'll see that later on, I bet. That seems to be Mars. Good solution, otherwise we would be here quite a long time. Yeah.
The Holocene has ended.
13.5
now and in the next few years
billion years.
will profoundly affect the next few thousand years.
Mars colony, I think that's a bit early there. I think
Conditions
2100.
have ever known so far are changing, and changing fast.
Nothing stays the same on this planet. Everything changes.
Yellowstone, I think that was Yellowstone, by the
Is
way.
going
Yeah.
into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping.
Oh, I remember that when he was
Things
there.
move on this planet. Things are not still. Everything is turning.
Antares, yeah. Yeah, Alpha Centauri, I think. Oh no, this is the super volcano, okay. Will we still be on Earth then? I don't know. Yeah, that takes some time because it's yeah, Betelgeuse. 4 million years. And what will be left after that? Yeah, because it disintegrates. And they just fade or fall onto Saturn. Was that Apophis? I don't know. Yeah, because they revert back to a Pangea-like structure. That's so cool.
As it begins to run out of fuel, the sun won't simply fade away to nothing.
Get bigger.
Its core will collapse, and the extra heat this generates will cause its outer layers to expand.
I think it will eat Mercury, and I think Venus as well. I'm not sure about that. Yeah. I don't think we will be there.
Dead. It remains slowly cooling in the freezing temperatures of deep space.
Yeah, so I would stop here for a while because we've seen quite a lot. And yeah, I mean, that's my biggest question currently is, will we still be there? I don't think so. And I don't mean that we are extinct. We might have evolved. I mean, 35 billion years, that is 3 times the age of the universe. So we won't be humans in any way. I don't think so. We might have founded a solar empire and died, and founded another one and died again, and I don't know, but it makes you wonder. Makes you really wonder, because I mean, it's the first thing we really have to contend with. I think, if nothing stupid happens, like a black hole crashing into our solar system or stuff like that, but or gamma ray bursts frying us, and they showed it there, and I don't know what they meant by that gamma ray burst. That was a bit confusing to me, but it's just because I didn't know what they wanted to tell me. Was it that it would hit Earth, or that it just would happen, which the latter one doesn't make sense. In the former, yeah, I don't think we should discuss Earth then, because I think it's gone. But it might be at the fringes, so it's like this. I've been talking about that when I talked about how likely it would be that a black hole crashes into the solar system. The reaction, so it's big space, and there's a tiny marble dot thing that's the Earth, and to hit that, very improbable, but if you shoot enough times, you might hit it. So, but yeah, I'm a bit sad that they didn't show that, but perhaps the time, because they are increasing the times, the speed they show things. I'm a bit sad that they did not really show Mercury being eaten by the sun. I am not sure if Venus will be eaten by the sun. I forgot that. I knew that one, but I don't remember. Yeah, but where will we be? And I think the question is useless here. No one knows. I don't know. No one knows. No one knows. It's quite, yeah, something we can't fathom. But yeah, so the solar system, that was the solar system, basically. Yeah. The thing with the moons and the rings, so yeah, the moon might get ripped apart by tidal forces, the moon of Mars, and the ring of Saturn will disperse, because yeah, I mean, it's like, and I might be not really completely correct with this, it's just my knowledge from other parts of physics. So if you have something orbiting Saturn, it is obviously not a perfect ellipsis, and it will get closer or farther away, but only in very small incremental steps. So like our moon, by the way, I don't know if you know this, every year it moves away by 0.001 millimeter. I don't know the number. I don't know that anymore, but I know it's moving away, and I know that the moon of Mars is actually getting closer. So yeah, yeah. I mean, that's something. So yeah, with time, everything will just disperse. Or might fall into things, but then they disperse as well. And here, yeah, the sun will not go supernova, not become a neutron star, will just get big, eat up Mercury, I think definitely. I'm pretty sure about that. And then Venus, then comes a white dwarf, and then it dies, goes out, just a lump of metal in space. And that's it for our solar system. And yeah, let's see where we continue from here on out. Music is beautiful, by the way. Hope it's not copyrighted, otherwise you won't see this video. Or you won't hear the music. You will just not hear the
same as for all stars.
narrator.
One day, they must all eventually die, and the cosmos will be plunged into eternal night.
All stars eventually will run out of fuel.
Yeah.
The temperature of the universe drops. The stars, one by one.
But that will take time. And you see here the time scale, trillions of years. because if a star dies and it's big enough, it will leave behind a nebula, and it might give birth to another star there. So that takes time, because it's not like there are stars and they go out. That's not like it. It's their new stars are born and die, and are born and die and again. And yeah, but there is a point where it's also expansion of the universe. I think it's bigger, and the energy density per volume decreases, so it's getting colder and colder and colder and colder, and the radiation is not produced anymore by the suns. It's produced by black holes, Hawking radiation, but they will probably tell me that. I'm sure they will. I'm sure they will.
Will turn off. And there'll be no more new stars created.
Yeah, one day.
And so that the universe will end not with a bang, but with a whimper.
The universe of light. The universe where we can see.
Not in fire, but in ice.
I'm sorry that I paused this. So there are other theories, I think, but I'm not sure. There might be this big crunch. And this is absolutely, I don't have any real clue about this. I've just read about this in my free time when I was a child. So I don't even know if it's still recent, because it was not in the lectures. Lectures are about like redshift and stuff like that. But I think it's the big crunch. Like it's all ripping apart because of expansion accelerates, as you might know. I think it does. I know there were new results for that one about acceleration and stuff like that, and I think it's accelerating. It has to do with dark energy, but don't nail me on that. Yeah, so it's gonna rip apart, or it's gonna expand, stop, and collapse into itself again, or it's just expanding and dying out. So yeah. Yeah, that's what I was talking about. There are still black holes though. Many black holes. But that would radiate light. Brown dwarf, I think it's called when it dies.
A white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night.
Yeah, but so it's not all starlight at its end, but yeah.
The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes.
Yeah. Yeah, and by the way, it's just something. I'm just gonna talk about it here. I will talk about it down the line anyway. And it's probably something you all know. But the star is not burning, it's doing fusion. So it's not like fire in a fireplace. It's not a chemical reaction. It's a plasma that is just and I don't know the English word. Aggregate. Like liquid, solid, and gaseous. Those and the third one is one of the. There are others, but you can say the commonly known fourth one is plasma, and plasma is like the thing that is where the nuclear fusion happens. So it's a process of nuclear fusion, not burning. Stars aren't burning. It depends on how do you define burning, of course, but it's not like fire is burning. It's different. It's not oxidizing like anything. Just wanted to say that because it's something that many people don't know, but I'm sure you know because it's you might know that. Yeah, and then we've got black holes and.
In some ways, it's kind of a ghost
Iron
It's the
corpses.
corpses, the zombie stars, that will take us into the future.
I'm pretty sure if there is something that is an ancestral entity, race, whatever of humans, they have already left the universe here. They have. Or they have found ways to reverse things that we think are absolutely fundamental laws of nature. You know, because this is already by far a time where a science fiction author couldn't dream up anything that would make sense to us nowadays. You know, if someone was really creative and thought about it, yeah, well, how could it look like? It's not, probably not anymore. In this time span, if there is a race that survives that time span, there's not gonna be something like, not like empires, countries, planetary countries, conglomerates, whatever. I don't think that is. It's too far gone. It's beyond imagination already. I can't fathom that. It's something you don't. I mean, you think about that sometimes, perhaps if you take a walk and have your thoughts run wild, but I don't think there are humans here anymore, or our ancestors, our the people that come after us. I don't think so. I don't think so. Personal opinion, but I don't think. 200 million trillion years, yeah. Yeah. But they should be massive. I don't understand this part. And I think it is because they already said stars are out. And I thought that was not, we had that, but it's currently or still happening. Just for you, perhaps you're as confused as I'm, perhaps I'm just being stupid again, but they are obviously alive and there are stars. They are just not forming from nebula, but from collisions, as they put it here, which is, I think, correct. So, yeah, it's still not the light death. And again, this comes more and more and more unlikely as the universe expands. So it's like the space between two stars expands also. So if you shoot a bullet, it's like this thing that I said earlier on with the wall. You know, there's a wall, there's a dot on the wall, you shoot at it, but the wall keeps getting bigger and bigger and bigger. And you know, and you shoot at the wall and you try to hit the dot, you try to guess where it is. And as the wall is expanding, it gets less and less and less likely that you hit it. So that's what this is. So I don't know how likely these collisions are, and when they are so unlikely that you would say, yeah, they don't happen anymore. Statistics. Or around black holes. Or around black holes. Because they might be able to harvest Hawking radiation in a way.
A black dwarf will be the final fate of those last
Ah,
stars.
black, not
White
brown,
dwarfs
but
that have
yeah.
become so cold that they barely emit any more heat or light.
It's so sad.
Black dwarfs are dark, dense, decaying balls of degenerate matter, little more than the ashes of stars. Their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun.
But they stay, I think. Let me think about that. They don't fall into black holes, they will stay. Because the gravity will hold the matter together, unless there's no, I think, no magnetism anymore. They will just be lumps that you could touch but not see. Yeah, that's so. I hate that thought. So unnerving.
Stars take so long to reach this point. We believe there are currently no black dwarves in the universe.
But to be fair, look at the time. 2,000 trillion years, whatever that number is. I don't even know if this is the right number, because normally you would write it as a power, 10 to the power of, I don't know, what is this? Trillion is probably... This is probably 15, 10 to the power of 15 years. I think. I might be wrong, because I don't know this trillion thing. And we in Germany have other words for these, but yeah, there are none. I mean, we are. It's like this happened right now. We had this happen. Don't know if you can hear me snapping my fingers, but that's where we are currently. Snap against the eternity of time. So yeah. So it might not even be the main. It is not the main thing that there's light. It's not the main thing of a universe that there's light. Yeah, there it is. But you won't see that because there's no light. But you might see this because of the accretion disk. Okay, you might see something like this. Oh, this is such a great thing. This is a simulation, I think, of a star being... Or it might even be real data that they used to animate this. A star that's just destroyed by a black hole. Yeah, then it's gobbled up. The singularity. Yeah. This is what a black hole looks like. The other one was not really. Because it's not flat.
Life that's based on really the energy available to us now. You could imagine living conscious systems which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal.
That's so strange.
Our life dies out. One could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence.
Yeah. Two things I think are interesting to me, at least. Don't know if they're to you. So the first one is, yeah, I mean, life is not like, it doesn't have to be a brain, might be a collective. And this is a trope in a way in science fiction, this swarm intelligence, either biological or nanite swarm, whatever. I think that's the likely thing. If they can repair themselves, and yeah, they that might be something, and they don't need heat energy, that perhaps they might harvest low frequency electromagnetic waves, or they might get close to black holes because they are tiny, so they can close enough and orbit it and get the angular momentum or the rotational energy and use it. Second thing, yeah, I'm this is something, of course, we don't know, but from a probabilistic standpoint, I think the universe is probably teeming with life. And by that, I don't mean that there's a lot of life per thousands of planets, but that there is not like, oh, there's perhaps another civilization somewhere in the universe. Or another planet where life exists. That might be just amoeba or something like that, but I think there is likely hundreds of civilizations at least. And yeah, Fermi paradox. I mean, I won't talk about that here in this one. It would just be too much. But yeah, I mean, look, it's so scary. Imagine that you're a civilization and it's not like there's light like we have it here, stars in the sky. It's just like you grow up. Let's imagine that you grow up on a planet and it's a bit like here, perhaps even. There's plant life. You were living in a cave. Look up at the sky and there's just a black ball where there's a ring around it and it's strange. Though, oh, that's cool. Just a thought, and might be stupid, but if you live on a planet that's orbiting a black hole in a stable orbit, which is obviously it's possible. Black hole's just a star if you are far enough away. Like the gravity is like a star. Just gets stronger in the middle of the solar black hole, whatever system. There it is really strong, you shouldn't go there, but it's like, I mean, if the sun was a black hole, we wouldn't notice in gravity. Everything would be the same. If we would get close, it would be bad. But, and that is my thought, if you are close to the black hole, you might get physics quicker to work because you can observe it, you can do experiments on it and stuff like that. And that is interesting. I think that's cool because we can just observe them from thousands of light years away. It's a bit exaggerated, but you know, it's just you can't directly observe them, can't do experiments on them. And imagine if you had a black hole and you were Einstein, and you would look at it and you would see that you can see the accretion disk from the top and the bottom because space is distorted and stuff like that. I think you could get several things like general relativity quicker. And you might get even the theory of everything, if it exists, quicker near a black hole. So it might actually be a good thing for developing an intelligent civilization, whatever it is. Just a thought. But yeah, it's scary. And it's, from our perspective, from my perspective, even more scary. Because I hate this darkness thing. I hate it. But we are only third in, so let's see where it goes. Ooh, that's... Yeah. Yeah. Those are... Again, I'm not sure, but I think that is a statement you have to not take it with a grain of salt because it's correct in a way, but you have to be careful to not get the wrong idea about that. It's like, yes, because expansion is like this. It's not like I take two balls and I shoot one in this direction and one in that direction. The space there, it's like, and I myself don't understand it completely. I have to admit that it's like the space appears in between. So you know, it's not like they're flying apart. Space-time expands itself. So the distance, it's like this distance would just suddenly turn into this distance. And what they are saying is that this growth by the models we are using now, I always say that and keep in mind, I mean, it might stop, whatever, but the models now predict, so to speak, that in this phase, the appearance, and it's not really appearance, it's just also a metaphor used here by me. I hope it's clear. So it's like this appearance of space makes these points, if you were an absolute observer, would make them get away quicker apart than the speed of light. So that means they are getting apart, and if this thing sends out a light, it wouldn't keep up with it, you know? It's, yeah, you wouldn't see the sky. Even if you were orbiting a black hole, you would see nothing. Even if there were still stars or galaxies or whatever out there, you wouldn't see them. Because the light can never reach us. It's like this, the known universe thing. And you probably know that as well. The known universe thing is like, how old is the universe? 13.5 billion years. So about, I think, I don't know how accurately we can determine it currently. But so take a point A, light travels from there, from the first second of the universe onwards, and you can just calculate a distance where that light will be in 13.5 billion years. So, and if you take that and do that in every direction, there's like this sphere you get, because you move in every direction with this speed of light thing, and you can calculate the distance it takes in this time, which is so unbelievably big that we can't even start to imagine it, but you know, the principle might be clear. So that also means that after, so for points that are farther away, I'm struggling a bit with English here, sorry, farther away, their light can't reach us. So we don't know. So there's this bubble that we are potentially knowledgeable about, but we don't know what's beyond. We can, and it's impossible if you don't get through wormholes or hyperspace or whatever you might think of, because you have to travel faster than the speed of light to get to those points, and so, and then the universe gets older, and light from farther away points can reach us. So our understanding of the universe also expands with time naturally, because light from farther away places reaches us. And sorry, I will watch it. I will continue watching this, but this is another thing which is interesting, and I love that. So theoretically, you would get, and you do get, not you would, you do get the Big Bang, because things at the Big Bang are reaching us now if they are the distance away that light needs to travel from 13.5 billion years ago. So that means, and it's background radiation, basically. So the radiation from the Big Bang that reaches us from these points, you can look at the Big Bang, or shortly after the Big Bang. At those moments, you can theoretically look at them. And that's so cool. I love that. And also, it's like, obviously we can't really do that, but it's like if you would look out of the window and you see there next to your car there is this French guy. Further down the road there are some Romans. Further down the road there are some dinosaurs, you know, and you see that because the light needed the time. It's like that, but on a bigger scale and not observable by eyes, obviously. But that is such a cool thought. I love that. But let's see where we get here, and I went on a tangent again. Yeah, so you won't get that knowledge anymore. But if you are orbiting a black hole, you might still get it because of wormholes. I don't know. They do.
One of the fundamental building blocks of atomic matter, what makes us up, can just
Oh.
spontaneously fall apart.
If there is someone in the comments that knows about this, because I would have to ask a colleague. And there are many of my more distant colleagues at my university that they are doing research on this. And they're doing these neutrino oscillation things in the Arctic and stuff like that. And I am not sure that, and this is from really a layman point as well, in this area. But also, the thing is, there are theories that would predict this. There are theories that would not predict this, I think. And we've never observed it. So we don't know. This is something that, to my knowledge, we don't know. But I think it's string theory, but don't nail me on this. Or don't I might be wrong. I think it's, if I remember correctly, it's string theory that predicts this. But I'm not sure. It might be absolute rubbish. But anyway, it's something that a theory currently predicts, and I don't know which one, I'm sorry, but it's a theory. So if we would observe proton decaying, that makes the theory more likely. If we don't, which we don't, they can say, yeah, it's we will never see that because it's so far in the future like this. So, but yeah, if this is true, of course they're right. So just, I think this is not safe knowledge. But yeah.
Any material that evades the pull of a black hole eventually dies away as its protons disintegrate.
And protons don't look like that. You can see them. By the way, as well. Just a metaphor, this thing, this ball thingy. But yeah, so what becomes of them? They turn into, I believe, charged particles, light, electromagnetic radiation, energy. I mean, they'd probably turn to energy. I imagine. I'm not sure what the theory exactly has for a mechanism there, but yeah. Oh. Okay, I'm a bit glad that I didn't talk out of my rear. But yeah. Anyway, so I'm glad that they put it in. Okay, and I'm not an idiot.
The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving
Radiation.
nothing behind.
Yep.
With the black dwarves gone, there won't be a single atom of matter left.
That's so scary. Perhaps consciousness.
All will remain
That was a
in the
joke.
once rich cosmos will be particles of light and black holes.
I'm sorry, this is something colleague of mine is yeah. I will this is obviously just an artistic take this as an absolutely artistic rendition of what a light particle looks like, because it's not even a particle in space, it's a particle in momentum space, which is abstract, and there's a lot to say there, but there are no things flying around. And if you even okay, you could say they are flying around, but not on paths. Not on paths. The paths from at least from all the theories, I think are very fruitful. This is not at all what it looks like. Not at all. And but it's I see this often. It looks like this. I hope it's the English name fog chamber. You know, where you see these traces of radiation with decays, alpha, beta, gamma decays. You can see them. But yeah, so you have to be careful about this. If you want to get into quantum physics, which is my area, so I can say this, you should be very, very careful with this part of the video. If you think about it, if you try to create your own pictures in your head, which you always should do, always do that when you're learning, create your own picture and then try to think for yourself, does the picture make sense? How does it work? If your picture doesn't work, take another picture. Don't fall in love with your pictures in your head. Whatever, but I'm sorry for that. It's just something that I know is one of the biggest problems when you try to learn quantum physics. And no, it is the biggest problem. Absolute biggest problem, exactly what I just said. So, and yeah, perhaps let me know in the comments. I'm interested in that as well, because there's not a lot of research done. And I'm gonna do research next year on this, but so what do you imagine a photon is? What do you imagine? And just post it. There's no right or wrong, because most people would say you can't answer and because it's too complicated. Just tell me. I'm just interested. It doesn't matter if you think it's wrong, if you know it's wrong. I don't care. I really don't care. It's not. Just tell me what you think a photon is, or how it looks like or behaves. I would be very interested in that. It would be very lovely if you told me, because yeah. Yeah, if we are not gone by then, there's no hope. Or after people. the people that come after us. Yes. Yes. Oh, that's a beautiful metaphor, because there is something. It's not empty because there are black holes. That is so interesting. That is so interesting. This icy death. And I want you to think about, why do they say this? Icy death. It's because we're humans. It's from our perspective. For us, as people and living things that need light to thrive, to live, it's an icy death. The universe, why would you say it's dead? Because it perhaps is not dead. Perhaps that's what it is supposed to be. Because if you... And the metaphor with the womb, again, I think it's right, because we don't know anything about this really, but there's this theory, and I've talked about it in another video already once, that the universe is that universes do grow and procreate, which is obviously the biological procreation by black holes. If you have a black hole, and it's not holographic theory, it is in a way, but it's more. So, yeah. So it's more, but it's like you have a black hole and you create another universe, and holographic theory is, it's not like it's there, but it's in another universe, parallel universe, whatever. And in that universe, there are the constants of nature are a bit different. So that's the theory, and it's just the hypothesis. I'm sorry, again, I do this all the time. Most of the time, if I say theory, it's hypothesis. So the hypothesis is, and it's just thought. It's just really creative thought, that so you have these different constants of nature, and they are a bit different. And so think about it. If there are constants that make the formation of black holes more probable, that would be a good universe for further procreation, because then the black holes would create other universes. You know what I mean? So if there are universes where there are less black holes, and this era might not even be, because there are not enough stars that are dense enough to become black holes, and that there are no supermassive black holes and whatever. And that might be that those just they're just like dead, because they don't procreate. They don't give life to other universes. So the universes with higher and higher probabilities to form black holes are more and more likely to be growing in this evolutionary process, which is all metaphor, of course. And so that might be the purpose. And I don't mean that in a like God gave this purpose, or an AI gave this purpose that is programming this matrix, whatever. I'm just making a bit of fun here, but you know, it's not like it's the purpose is like the purpose of humans is to procreate. Let's say that. You might argue that, let's just take that as a premise. If you say that that's our purpose, and the purpose of the universe is to create more and more universes where more and more black holes are formed, so we create more and more universe, so it procreates as well. That's the hypothesis of evolution of universes, and it's absolutely just creative idea. No, not a single proof for that. Save for, and this is not a proof or anything, this makes me think a bit about that, because this means that, because this makes me realize this time scale here. I haven't seen this time scale ever, how the times in the universe are. And if they say, and they're right because they looked at this time scale before and told me that the black hole era is like after it's from the womb, which they might have chosen purposely or not. So that makes me think that yeah, that might be the universe how it should be, if you know what I mean. I hope I made this a bit clear. I hope it's my English wasn't too bad or stuff. You know, I hope I carried the idea across a bit. So yeah, let's just continue. Hope I don't go on another tangent just in 2 seconds. But yeah, this icy death thing, you have to think about that because that's perspective. It's so human perspective.
Creates a bright window in the universe's adolescence, during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life, as we know it, is only possible for 1,000th of a billion billionth of a percent.
Yeah. See? From our perspective. Yeah, and I don't know if you know this, black holes do evaporate, but the bigger they are, the slower they shrink. So yeah, I got that wrong in the one video about black holes. So yeah, so if you have a proton-sized black hole, it will almost instantly, I think even below Planck time, evaporate. But if you have a big one, it will shrink slowly and accelerate shrinking. So yeah, I got that one wrong in the other because I missed the sign in front of the power. But yeah, so that's something. That's really something. So after that, there's truly nothing. But it might have done what it was supposed to do. It might have created more universes. Saying, no, I just like this idea. It doesn't matter for us currently because, you know, obviously it doesn't matter for us. It's just such a great thought. I love that thought. It's so cool. Probably just a thought, but I hope they will talk about this black hole era more though, because I really like that idea. There we have a black hole. That is actually
become the fundamental building block of the
yeah.
universe. A galaxy will basically be a supermassive black hole in a center with smaller black holes orbiting it.
Zombie galaxies filled with black holes continue to evolve.
They'll eat each other and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales you're talking about are now trillions of years instead of thousands or millions of years.
Yeah. Also, that is something, you know, perhaps this theory that, yeah, the planets are just particles and there is a bigger universe that we are living in, so to speak, but like the sun is a proton and because it looks like the atom, or it doesn't, that's rubbish, of course. But here you might think, okay, but now that's true. And you might say that because actually interactions between particles in quantum physics and quantum field theory and beyond are, I think, almost the same as wormholes. There are very, very big parallels between interactions and wormholes. Because interactions are and I will not say a lot about this here because I'm already at 52 minutes. I haven't even watched half the video. But yeah, so entanglement is like interaction is like particles entangling, and that's like a wormhole. And a wormhole is similar to a black hole because of several recent theories, hypotheses in new theories. So yeah, but still it's not, because quantum nature is not here. You know, this would have to have quantum nature. Apparently it doesn't, or it might have, I'm not sure, but yeah, it's fun. So fun to think about. I hope I'm not boring you. probably have already switched off, but yeah. Yeah, gravity waves. But that's not that much. It's much, a lot, it's a lot, but compared to those time scales. Yeah,
Black
yeah.
holes can bang on space-time like mallets on a drum.
That's a beautiful statement.
And they have a very characteristic song.
And they try.
Two black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time.
Figuratively speaking. Yeah. They actually do experiments with black holes, by the way, using sound. So they have analogy experiments where they get quite some new
Space
understandings.
squeezes and stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves. They are literally the sounds of space ringing, and they will travel out from these black holes.
What? Literally? Be careful with literally. No, metaphorically. Jesus Christ, no, no, woman. Sorry. I'm being a pooper here.
If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound.
Perhaps I would. Okay, if she says it this way, I might be wrong here.
Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close.
I'm not sure about this part actually. She might be right. She's probably right. She's gonna. I think she sounds like an expert. She sure is an expert.
Faster and it gets louder.
No, no, because there's no air. There's no air. You wouldn't hear anything. If there was air still there, yeah, you would hear it. Of course you would. No, duh. But no, you wouldn't hear it.
Black holes were immortal, but even these one day die.
So, she's right if you say you're standing on a planet next to it. With air, with something, with a medium that can transmit the waves, so because you can't hear. This is really stupid of me, but it's really party pooping here, but yeah.
Now we're talking about timescales of unimaginable length, quadrillions of years.
And what number is that? 10 to the power of
even the black holes begin to evaporate.
9, 18, 27, 36. Ooh.
According to quantum mechanics, space is filled with virtual particles, antiparticles, that are constantly materializing in pairs, separating, coming together again, and annihilating each other.
Yes, he's right. I mean, Stephen Hawking, of course he's right. That's very interesting. Very interesting, because it's actually quantum, do you say, not oscillations, but some twists and oscillations in quantum, in the quantum nature, so to speak. It's very interesting. Virtual particles, well, they're not little balls that appear. Nothing. It's just like the universe has this field, you know, and it does things. And that's if it does certain things, these virtual particles emerge for a certain time.
In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal.
Yeah, Hawking radiation, yeah.
They evaporate away at an increasing rate until they vanish in a gigantic explosion.
There the photons are flying again, which is
Quantum
rubbish.
mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole.
Yeah, because as it goes faster and faster and faster, the evaporation, it's more and more and more and more and more light, you know? You wouldn't, yeah, these are, I think they are trying to depict photons here again, which I absolutely can't stand. From a physics point of view, but aesthetically it's very beautiful. Very beautiful, very Fantasia-like. Yeah. If that force even exists in the way we think it works. Like energy.
Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice. Trillions upon trillions of years from now.
Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff...
Oh yeah, I talked about this earlier.
...radiation or whatever, there is still energy even in the space itself. And this energy, according to Einstein, exerts a push on the universe.
What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe. Almost 3/4 of the matter-energy content of the universe is this dark energy. And we don't know what it is.
Yeah, it's so weird. What is that?
Energy, unlike
Does it
matter
exist?
radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future.
So
Even
what will
Carol.
be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever.
What is that? What is that? What is...
Faster and faster and faster with time. A runaway universe.
What is this graphic?
70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be.
Might.
We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins. And that's why we want to know and study this subject.
Yeah, that's really true. Good that you said that. Yeah. Because this is just a projection. It's like with climate, you have no clue in 1,000 years. Yeah, oh, well, okay, they put it here. Okay, yeah. Yeah. Yes, because, yeah, okay. I should not have talked for so long at the beginning, I'm sorry. Interesting that they incorporated it here. I think it's not that well known. I mean, the parallel universe thing, yes, but okay, perhaps not this why it's happening. Yeah.
The forecast does seem to be for an ever colder, ever emptier universe. But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
Perhaps they're already there.
We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can concentrate tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe.
See, there's again this parallel to the black hole. Because that's what would happen. There's a small volume, you deposit a lot of energy there on a point, but then again we have problems there because we don't even know if there's a point, if that exists. Or if Planck cells are the only thing that, whatever. But yeah, so this is again parallels to black holes. And this is just me saying this is a nice idea, not that it's this way, by no means. I hope you don't understand it in that way. I don't want to say that. But this is so cool. I love this so much. They're doing a good job with the video. I don't like the visuals in a physics way. I love the visuals from an aesthetic point. Very great visuals. Beautiful to look at, great music. Let's see what they do now.
Facing the death of everything there is, this perhaps is their only possibility of escape. And this also raises a very intriguing possibility, sheer speculation of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and proliferate child universes. So an evolution may take among universes in the multiverse. Survival of the fittest may take place.
Interesting, I wouldn't have thought they would do that.
Do not have intelligent life are infertile.
Interesting.
They have no children. But those universes that have mild temperatures, stars like us, would create civilizations that could open up child universes, and they would then proliferate.
Again, this human point, I love this. I love it so much. It's so great. It's like, but if there's, it's like this, and I don't want to be mean to these people or something. I don't mean it this way, but it's like this perspective. It has to be live. It has to create. You know, this idea that perhaps it's just nature itself that creates with the black holes. Though both, I mean, those theories are similar. I would even argue it's the same because they here try to create black holes to create new universes. I'm strawmanning a bit here. I'm sorry. You have to. I hope you understand that, but that's so cool. Yeah, but it's again this live perspective that there's sentience that has to create it. I think that's so fascinating. Might be, yes, it might be. Might also not be. It's so great. So much potential here. Oh, I love this. So great. This video is very good. From a visual point of, yeah. Yeah. Entropy. The world killer. The last flash. Light. Or of radiation. Looks like a Deledon. Dandelion? I don't know how you pronounce that thing, you know. Beautiful. Beautiful imagery. It wouldn't look like this. Not in the it would, you know, of course not, but it's so good to look at. It's so good to look at. Beautiful. Beautiful music.
After an unimaginable length of time.
Yeah, this one.
The black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero.
Not to absolute zero. About. Infinitely close to, but not to that point, because there's always there is always virtual fluctuations still happening, and there are things connected with that as well, but they obviously don't go into that here. I wouldn't in their place either. But it's so black void of eternity.
Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end.
Yeah.
For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and it keeps not happening forever.
I love those quotes. Yeah. Well done. Well done. That's a very, very interesting, great video. From a physics perspective, what they said, I think that was beautifully done. A lot of nice hypotheses, thoughts carried over. Some stuff I never thought about before. Not a lot, but some stuff. And I personally loved the visualizations. I loved them. It was very beautiful. The music fit. It was like this. It's like Fantasia. I don't. You might know that one from Disney, the old one, where you just sit there and this music, and here interwoven with this narration, just had the beautiful images, and I loved that a lot. It's scientifically, when it came to the part where there was no visible light, it got a bit wonky on the physics side from the things they showed, which is okay, and not even that sounds stupid. It's great. I like it personally because I don't care. I know how this is just artistic. I just want you to know that you shouldn't think that this is what it really would look like. But it's a great video. Beautiful video. I really did enjoy it. So Andreas, thank you for recommending this. It's marvelously done, well crafted. Like the quotes, and I'm not sure how they did it, because I think those are archive footage, not footage, archive audio from Stephen and from Carol, Sean Carroll, Stephen Hawking, others. Yeah, I really, really, really did enjoy this. That was good. That was really good. Nice to see. I hope I did not ramble and too much, but yeah, How did you like this? Let me know. Did you like the imagery? Did you like the sound, the narration? Do you think it's okay to, and this is something, there is no right or wrong, I think, and I've talked to many people about this. Do you think you should visualize things artistically, whilst there is the scientific explanation, even though these images themselves are in this here only in some parts, but they're not scientifically really accurate? Is that okay? Should you be careful? You know, what's your opinion? I'm yeah. Anyway, I hope that you enjoyed this. I did, and yeah, if you like this commentary of this stupid old fool here, consider liking, subscribing perhaps, and have some fun. I do these once a week. I try to do it once a week. I will continue my spin series next week because that's something I know more about. And yeah, so hope you have a great day, great week, and yeah, see you again perhaps. Take care. Bye.